This is Chemistry Made Simple channel. I take this opportunity to welcome you to another great learning segment. Today, we look at the specific nomenclature of a group of compounds known as ethers. First things first, what are ethers? A simple explanation is that ethers is a family of organic compounds that can be represented by the general formula displayed besides here. Note that in the displayed general formula, R can stand for an alkyl group or an aryl group. Now, how do we name ethers? Now, according to Iupac, as a general rule, the name of the ether must have two parts. That is, the first part, we write the two alkyl substituents attached to the ether in alphabetical order, followed by the word ether. For example, the ether displayed besides here has a methyl group and an ethyl group. Therefore, by basing on the above rule, that its name is going to be ethyl, leave some space, methyl, leave some other space, ether. Now, we do not write the words ethyl, methyl, ether together. We have to separate the words, unlike in the previous part. Example 2 displayed there is methyl phenyl ether. This is what we also called anisole, if you still remember. Example 3 displayed there is tertiary butyl phenyl ether. Now notice that the tertiary butyl group can also be known as neobutyl, and therefore this compound can also be known as neobutyl phenyl ether. So sometimes we may treat the alkyl oxide group of the ether as a substituent, and specifically will be known as alkoxy. For example, displayed besides me, that one will be known as methoxy. Also displayed there will be ethoxy. And finally, displayed there also will be phenoxy. And when do we really treat this as a substituent? We treat it as a substituent in two cases. In the first case is when the compound has another longer carbon-carbon chain as compared to the carbon chain associated with the alkoxy group. That is the first case. And in the second case, the alkoxy group is also treated as a substituent when there is any other functional group in the compound. For example, to illustrate this rule, we are supposed to name example 1. By following that rule, realize that the parent chain is hexane because there are 6 carbon atoms, while the methoxide is a substituent that is attached to the third position. And therefore, the name of that compound according to Iupac guidelines will be 3-methoxyhexane. Second example to illustrate this guideline in the nomenclature of ethers is that we do have a cyclic alkene, and on this cyclic alkene there is an ethoxy substituent. So therefore, by numbering starting from the carbon-carbon double bond, we obtain that the ethoxy substituent is actually on position number 4. And therefore, the name of this compound is going to be, according to Iupac, 4-ethoxy, and then the parent name. What is the parent name? The parent name is cyclohex-1-ene. And our final example to illustrate the second guideline there is that we do have two methoxy groups that have been attached to our carbon-carbon chain there. But notice that the carbon-carbon chain has a carbon-carbon triple bond. That is another functional group. And therefore, the parent chain must be the one that contains that carbon-to-carbon triple bond. So by assigning numbers to the parent chain, we identify that the two methoxy groups are on carbon number 3 and carbon number 4. Therefore, the name of the compound is going to be 3,4-dimethoxy hept-1-ine. And finally, let us consider Iupac guidelines as required in the naming of cyclic ethers. According to Iupac, we use the prefix oxa followed by the name of the corresponding cyclic alkane. For example, displayed there, the structure of the ether corresponds to cyclopropane, and therefore, according to the guideline above, the name becomes oxacyclopropane. The second example displayed there is that the ether corresponds to the cyclic alkane cyclopentane. By using the above rule, the name of this ether is therefore going to be oxacyclopentane. Notice that this is also known as tetrahydrofuran. And finally, to illustrate the above rule, we do have an ether that has two oxygen linkages, and the cyclic alkane that corresponds to this is cyclohexane. So how do we name this? So by counting is that we establish that the two oxygen linkages in our ether are on position number 1 and position number 4. And therefore, according to Iupac, the name of this ether is going to be 1,4-dioxacyclohexane. At this point, I welcome you to our classroom where we are actively going to apply the rules to name the given compounds. Ladies and gentlemen, welcome to the classroom. Before us is the question that we are supposed to answer. We're supposed to name these two compounds. I would like to start with part B. The alka oxide group, this one, is going to be treated as a what? As a substituent. Why do we treat this as a substituent? It is because we already have another functional group in the compound. And if we treat this as a substituent, this is known as methoxy. So the parent chain is therefore going to be this. This becomes our parent chain. We proceed and assign numbers to carbon atoms on our parent chain. So this is number 1, this is number 2, number 3, number 4, and number 5. We identify that the carbon-carbon double bond is on number 1, and our alka-oxy, and for this case methoxy substituent, is on carbon atom number 4. And do not forget that the parent name of this, or the name of this, is to deal with from our previous work. This is our parent name. So finally, we can now write the Iupac name of this compound as on position 4 we have a methoxy group followed by the parent name. As simple as that. Now, going to our first question, part A, remember I changed the order, is that realize we do have two similar alkyl groups on our compound. This one and this one are the same, and each of them is an isopropyl group. So each of them is isopropyl. We also call this one secondary propyl in our previous work. So therefore, without wasting time, we can now write the name of our compound here as di. Why di? Because there are two similar groups, isopropyl followed by the word ether. We could also use the alternative as di secondary so these are the two correct Iupac names that we have derived for the given compounds. At this point, I want to wholeheartedly thank you for being part of this great learning experience. Do you have any challenging concept as regards organic chemistry? Please contact me by sending me an email using the email address in the description of this video, and I will humbly get back to you. Until next time, I remain yours, your chemistry teacher. Goodbye.